Now we're looking at lecture for 6.2. These are some things I want you to be aware of here for the exponential form in relation to compound interest formula here. You can see right here the three equations they have. Y is equal to A times B to the x power. A is the initial value. B is the positive constant, and it's called the growth decay factor, or the base. Compound interest is a standard example of an exponential function in which the function is written in this form here, using P, for example, P0 for the initial value, and R for the growth decay rate, and they have T for time in this one here. When I have X there, they put a T for time. Okay. So you can see the relationship between the two. That initial factor there, the initial value, and it's equal to A. Also, you can see that e to the k is the same thing as 1 plus r. And in these two formulas here, there's two different growth decay units. One is for a continuous function, and one is for a discrete function, which gives growth and decay per unit. And this is a growth decay for a continuous function here. And this is for more or less a discrete function here, which should give you an actual number. Okay. And let's take a look at some examples in 6.2. Now this one here, they ask you to represent e to the k as a decimal. So in your calculator, you can find this on your calculator. You can do this on your calculator, e to the x button. You can find the actual value here. Okay. And recall here that e to the k is the same thing as 1 plus r. So e to the k is the same thing as 1 plus r here. So we can rewrite this, get another equation from it, since we know that e to the k is the same thing as 1 plus r. We found that value for 1 plus r, we can replace it. And then we can rewrite it here into a form that's the choice the computer offers as an example. So 1 plus 0.0882 is the same thing as 1 plus 8.82%. And that gives us our new equation for this one here, for the B part of it. And this one here asks you, what is the continuous decay rate per year? So they're asking about the k value. So we look at the function here, we see that the k value is equal to a negative 0.0754. And they describe it here as a negative. Okay. So when they want to describe it here, they say that the function is decreasing, and they take the negative off at a rate of 7.54. That's how they ask you to describe it here. When is it not continuous? So they're asking us to give you a hint here. They ask for R. Consider the identity. They're asking for R. Okay, so we already know that e to the k is equal to 1 plus r. So we can find e to the k, and it'll give us 1 plus r. But they want to know what r is equal to. So I subtract 1 from both sides. And that gives me my r value here. Then they say write it as a percent. That would be a negative 7.26%. Then they ask you to write it in the form with P0 here. So you can line these up. We can line these up here. We already know what e to the k is equal to 1 plus r. So I already found 1 plus e to the k is going to be this number here. So I can replace it. And my initial value is going to get replaced, and that becomes my new equation. Then they want you to determine the value here for when t is 8. So I'll let t equal to 8, replace it here. So I have 0.9274 raised to the 8th power times 230,000. It gives me that value there. So you can see that. I let t equal to 8, and then I plugged in. This one here, complete parts A through C, create an exponential function. Okay. So in this particular population has a initial population of 76,000, and it grows at a rate of 3% per year. Okay. So my R is 3% per year, increasing. So I plug in here. Alright. So since it says it grows, R is going to be positive for growth. And then they ask us to fill in a table for each year. So here I have complete the table for 1 to 10. I let t equal to 1, then I solve for it. Then I let t equal to 0, and I solve for it. Then I let t equal to 1, then 2, and then 3. And I complete the table. Just like changing the value of t, which is right there. And I fill in the table. Then they ask you to graph it. Okay. Now you can also, since you have this function here, you can also put this into your graphing calculator and graph it. It's just let the t represent the x. Y would look something like, let's see here. Or you can just make a table of values here and graph it. So I probably would just make a table of values and just graph it. 0, 1, 2, 3, 4 up to 10. That'll be the easier way, I think. Air pressure can be modeled by the exponential equation given there. Y equal to 14.7 times e to the negative 0.0431 x, where x is an altitude of thousands of feet and y is air pressure. So for this one here, notice it said x represents thousands of feet. So if x was 2, that would represent 2,000 feet. If x was 3, that would represent 3,000 feet, and so on. So they want to know what is the continuous decay rate at 1,000 feet. Then they give you a hint there. They're looking for what decay would be. So from inspection, when we look at it, we can identify what K is. Okay. You see it's negative there, so that means it's decreasing. And as a percent, that's going to be a negative 4.31%. Okay. So it's decreasing. You wouldn't write the negative in there. You would just say it's decreasing at a rate of 4.31%. The B part here wants to know what is the decay rate for when it's not continuous. You already know the relationship between e to the k is equal to 1 plus r. So we find e to the k, subtract 1 from it, and then we'll have r. So on our calculators, we could find e to the k to be 0.9578 and subtract 1 from it. And that gives us our r value. By the same token here, we can extend that and say 1 plus r is equal to 0.9578. At the end, that is decreasing here, so that is our r there. You can see that. That should be negative 4.22% for my r. As a percent. Then they ask us to write n as, so see the r is a 4.22% negative. So they rewrite the equation in that form. So I have my exponential equation here, and right there underneath it, I can identify what my 1 plus r is. I already found 1 plus r to be 0.9578. My P0 in this case is 14.7. So there we have it there. There's our equation. And then they ask you what is the altitude at 3,500 feet. Okay. So in this case here, we want to we let x equal to 35. And then we plug in 3.25 psi. And then they what is the at sea level. At sea level, the altitude is 0. So we replace the altitude for 0, x equals 0 here. And anything to the 0 power is equal to 1. So we have 14.7 psi for that one there.